Namaste and welcome back to JEE Chemistry with Typical Monk. This is Class 33, Organic Chemistry, Part 8, the amines and diazonium salts. You have a carbon chain, a nitrogen atom, and you have an amine, ammonia with its hydrogen swapped for carbon groups. That nitrogen keeps a lone pair, and the lone pair makes the amine basic, ready to grab a proton and to steer every reaction. Cool a primary aromatic amine with nitrous acid, and something remarkable appears, a diazonium salt, a molecule so versatile it becomes a workshop, trading its nitrogen for a halide, a hydroxyl, a nitrile, or a brilliant dye. Learn the basicity order, the ways to build an amine, and the reactions of the diazonium salt, and the nitrogen chemistry of the exam is yours. Today, amines and diazonium salts, one idea at a time. Here is what you will master today. First, classification and nomenclature. Second, the basicity of amines. Third, the preparation of amines. Fourth, the diazonium salt and its reactions. And fifth, the distinguishing tests. One idea at a time. Let us set the foundation. An amine. It is ammonia with one or more of its hydrogens replaced by an alkyl or an aryl group. Classification: primary, secondary, or tertiary by the number of carbon groups on the nitrogen. Basicity: the lone pair on the nitrogen is what makes an amine basic. Master line: the nitrogen lone pair drives the whole of the chemistry. Now look at the picture, the basicity of amines. Amines are basic. The nitrogen's lone pair reaches out and accepts a proton, forming an ammonium ion. The order in water: secondary over primary over tertiary over ammonia, the result of a balance of effects. Aromatic amines: these are weaker bases because the lone pair is delocalized into the ring. Substituents: electron donating groups strengthen the base, electron withdrawing groups weaken it. Now, how an amine is made. Reduction of nitro compounds, nitrols, or amides, all the way down to amines. Nomonolysis: alkyl halides react with ammonia, but this gives a mixture of amines. Gabriel synthesis: it makes a pure primary amine, but for aliphatic amines only. Hoffman bromamide: an amide loses one carbon to give a primary amine. Now the reactions of amines. As a base, it forms salts with acids. Acylation: with acyl chlorides, it gives an amide. The carbylamine test: a primary amine with chloroform and potassium hydroxide gives a foul-smelling isocyanide. With nitrous acid, a primary aliphatic amine gives an alcohol and nitrogen gas, but a primary aromatic amine gives a diazonium salt. Electrophilic substitution: aniline is activating and ortho and para directing. Now look at the picture, the diazonium salt and all it can become. The diazonium salt, it is formed by treating aniline with nitrous acid at a low temperature. Sandmeyer: with a copper halide, it gives an aryl halide. Replacement: the diazonium group can be replaced by a hydroxyl, by a cyanide, by an iodide, or by a hydrogen. Azo coupling: with phenol or an amine, it couples to form a brightly colored azo dye. Now, the reactions of the diazonium salt, one by one. Formation: aniline with nitrous acid at 0 to 5 degrees gives benzene diazonium chloride. Sandmeyer: with copper chloride, copper bromide, or copper cyanide, it gives the aryl halide or nitrile. Catman: with copper powder and the hydrogen halide, an alternative to Sandmeyer. Replacement: warm water gives phenol, potassium iodide gives the iodide, and hypophosphorus acid gives benzene. Azo coupling: with phenol or aniline, it gives a brightly colored azo dye. Now the tests that tell the amines apart. The Hinsberg test: it distinguishes primary, secondary, and tertiary amines. The carbylamine test: only primary amines give the foul isocyanide smell. Nitrous acid: primary aromatic amines give a stable diazonium salt, but only in the cold. Now match each clue to its reaction. The lone pair accepting a proton goes to basicity. Aniline with cold nitrous acid goes to a diazonium salt. A diazonium salt with copper chloride goes to the Sand-Meyer reaction. And a primary amine with chloroform and potassium hydroxide goes to the carbylamine test. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. Amines are basic because of the nitrogen lone pair. Correct. Statement 2. Aromatic amines are stronger bases than aliphatic ones. Wrong, they are weaker. Statement 3. The carbylamine test is given only by primary amines. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the aromatic amine in statement 2. Now, the 2 mistakes that quietly cost marks. The truth, aromatic amines are weaker bases because the lone pair is delocalized into the ring. The trap, thinking that aniline is a stronger base than ethylamine, it is not. The second truth, only primary amines give the carbylamine test. The second trap, forgetting that the diazonium salt is stable only at a low temperature. Now test yourself. Answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. What makes an amine basic? The nitrogen lone pair. Question 2. Which is the stronger base, an aliphatic or aromatic amine? The aliphatic. Question 3. Aniline with cold nitrous acid gives a diazonium salt. Question 4. A diazonium salt with copper cyanide is the Sand-Meyer reaction. And question 5. The test that only primary amines give? The carbylamine test. Let us gather it all in one breath. Amines are ammonia with alkyl or aryl groups, classified as primary, secondary or tertiary. They are basic because of the nitrogen lone pair, and aromatic amines are weaker. They are prepared by reduction, by Gabriel, and by Hoffman. The diazonium salt comes from aniline plus cold nitrous acid. Then, Sand-Meyer, replacement, and azo coupling. Next class, the biomolecules and the polymers. The lone pair does it all. Nearly every reaction of an amine begins with the same small thing, the lone pair on its nitrogen. It reaches out to grab a proton, which makes the amine basic. It directs a ring towards substitution, and in a primary aromatic amine, treated cold with nitrous acid, it gives rise to the diazonium salt, one of the most useful intermediates in all of organic chemistry. From that salt flow aryl halides by Sand-Meyer, phenols and nitriles by replacement, and the vivid colors of the azo dyes. Learn the basicity order and the diazonium reactions, and the nitrogen chemistry falls into a clear line. Next class, the biomolecules and polymers. Sarah, David, Lisa, and John all begin exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.